Hello everyone. So today we're going to continue with lesson 1.5. And what we're going to be talking about today is really using a protractor and also a few rules about angles so you can do some algebra in just a moment. So let's start with what we need to know about angles in general. The first thing that we need to know is that there are four main types of angles. We're going to talk about acute angles, we're going to talk about obtuse, right, and straight angles. Now with these four, there are a few pieces of information for each one. First off, an acute angle is any angle that's less than 90 degrees. And that means that it's going to be fairly small. You can even think, "Aw, cute," to remember. I'll just say that one. And yes, the more ridiculous it is, the easier it is to remember. So for our next one, when we're talking about obtuse angles, they're not going to be less than 90, they're going to be greater than 90. And I like to remember this as obese and obtuse have like that same root word, so they're both big things, right? It's bigger than 90, it's going to be a wide opening. Now with right, I'd like you to underline, highlight, or use like a different color here because right angles are special, and that's because right angles are exactly 90 degrees. And anytime you have something that is exact, it means that you can have an equal sign, and that means that it could be potentially used to create a formula. And we're going to be always looking for things that we can turn into formulas in geometry. One other thing to remember with right angles is they're going to be marked on a picture with this little box here. Now, as soon as you see that, you know that it's a right angle, you know that it's 90 degrees. But if you are given these two lines without that box, you cannot assume that it's 90 degrees, even if it looks pretty stinking close to 90. Well, that leads us to our straight angle, and this is another one that I'd like you to do in another color pen or highlighted, and this would be an angle that is 180 degrees. That's exactly what it sounds like. It's going to be a straight line, and the vertex is going to be somewhere in the center. Now typically you aren't going to see very many straight angles where it's just the straight angle by itself, but straight angles make appearances in problems where you're going to see something like this, one long line with a bunch of smaller lines coming off of it. Now the reason why this is so important is because if I wanted to find the measure of any of the angles in here, I can actually use the fact that they all add up to 180 to help solve for those angles. And we're going to do that in a little bit. But first, we're going to practice how to use a protractor. Now, your protractor might look different, but this is the one that I'm going to be using mostly in class. And there are a few things to note. First, I'm going to talk about the center of the protractor. That is this hole here, or sometimes it's going to be up here. The next thing that you're going to see on this that I'm going to refer to is what I call the zero line. And the zero line is just the line that lines up along the flat side. Again, it could be along here in your protractor, it could be in the center like this one, or on this one on my paper, it's this line along the bottom. The zero line is the line that lines up with the zeros. When you are trying to measure an angle, you have to be careful that you line up your vertex with the center. So if I'm measuring this one here, I want to make sure that my vertex is on the center there. Second, I want to make sure that my zero line lines up with one of the sides of my protractor. So you can see that here, this line, my zero line, lines up with one of the sides. And last but not least, you're going to extend the other line. Now you can do that physically by drawing it in, or you can just take a pen or pencil and extend it in this way. Now you might notice that there are two numbers that are being hit here by this line, and that is about an 81 and something like 100 about. If you have to decide between those two, remember that this angle, if it's acute, should be the smaller number. If the angle is large, it should be a larger number. So since this is less than 90 acute, that means that this would be an 81 degree angle, the smaller of the two numbers that I saw. That's in contrast to this one here. This is an obtuse angle, so I'm going to be looking at the larger of the two numbers that I see. And again, I can kind of extend it up. I can extend my line over here, and I get to be about 128 degrees. I'm going to leave the other ones If you have any questions, don't be afraid to ask me via email or in person when you return. For our next part, we're going to talk about two quick terms. The first one is adjacent angles. Adjacent angles are just angles that share a side. So they're going to share a single side, and they'll look oftentimes something like this, where you have angles 1 and 2 as adjacent angles. Of course, if I have a straight line angle with 1 and 2 over here, these two are also adjacent angles. They're just sharing a side. Congruent angles, on the other hand, are a lot like what we talked about yesterday with congruent segments. Congruent angles are angles that are equal in measure. When we are writing them out, let's start with a picture. So if these are my two angles, I can have labels here where A is the vertex, and I have points B, C, and D as points along the side. Now here, let's say I wanted to say that this angle and this angle are congruent. Well, I can actually do that with a symbol. I can do it by just adding these little curved lines. That just means that these two things are equal in measure, or their angles are congruent. Sometimes you'll see this additional dash through it, and that's just to clarify that they are talking about equality. If you see that this one had like 2 lines and this one only had 1, that would be saying that those two are different and not equal. We'll see some more of that tomorrow though. Now let's say I want to write this out in notation. Here's how your book's going to do it. They're going to use the congruency sign that we used yesterday with segments. Only this time, instead of segments, we're talking about angles. So you're going to see the little angle mark. Now they're going to name each angle, and remember you're doing it so that someone could draw in that angle. So if I start with B, so I wouldn't have to lift up my pencil, I'd move to A and go to C. So that would be BAC, or you could do it the other way, CAB. That'd be the same thing. And on the other side, I'd have CAD or DAC. Just make sure that the vertex is in the center. Remember that mathematicians are a little bit lazy, so they might put in 1s and 2s here and just call this angle 1 and angle 2 and tell you that those two angles are congruent. Now when we're talking about them being equal in measure, they'll just add a little measurement mark. So they'll say the measure of angle 1 and the measure of angle 2 are equal, rather than angle 1 and angle 2 are congruent. I'm not going to be very picky with these signs, but it's good to know the difference, and it's definitely good to know that the M is telling you it wants the measure or an actual number for your answer. Now let's use these ideas and the formulas that we have with right and straight angles to help solve these two problems. Now you're basically going to be able to set up an equation using either the idea that it adds up to 90 or 180, or the idea that two angles are congruent and therefore equal to each other. And you'll use those two ideas to solve these problems and the ones in your book. So we're going to start with this one here. Let's say for this question, I wanted to find what is x equal to. And this one unfortunately got a little bit cut off. This should have 3x in here. So we're going to assume that was already written in. Now when I'm looking for this, it is not told to me that these two angles are congruent. So I cannot assume that these two are equal in measure. But I am told that these two form a right angle. CAD is a right angle according to this little box. So that means that those two add up to 90 degrees. And don't forget, if you know that they add up to 90 degrees, it means you have an equation. And part of our goal in geometry is to find a way to get this into an equation. So I can take this, 3x, and I can add it to my other angle, DAB, which is 7x minus 4. And at this point, I'm going to be doing my algebra to solve for x. So combining these, I'm going to get 10x minus 4 is equal to 90. Add 4 to both sides to get 94 is equal to 10x, and divide by 10 to get x is equal to 9.4. Could I solve for the angles from there? Definitely. I could put x in for this angle or x in for this angle and continue on, but my question doesn't ask for that, so I would be done at this point. Now when I move on to the next one though, In this one, I don't have a right angle, I don't have a straight angle, so I don't actually know what these two angles add up together to be. But I do have that these two things are equal, right? I had that little curved mark, so that means that these two things are congruent and their measures are equal. So I'm just going to call this, just for my own sanity, measure of angle 1 and measure of angle 2. And since measure of angle 1 equals measure of angle 2, I can substitute those into the formula where measure of angle 1 is x plus 40 and measure of angle 2 is 3x minus 20. Here I can solve for x by combining like terms, and I'm going to subtract x from both sides to get 2x on this side. And since I would really like to not have the 20 on this side, I'm going to add 20 to both sides to get 60 over here. Divide both sides by 2, and I end up with 30 is equal to x. Now that's really nice to know, but let's say the question was not asking what is x, and instead the question just says m and angle, and we're going to do PRQ here. Excuse the scribbles. Now in this case it's saying I want to know the measure of angle PRQ. So PRQ is this one, so it's x plus 40. Substitute 30 in for x, that gives you 70. 30 plus 40 is 70. So I know that PRQ has a measure of 70 degrees, and that would be my final answer. One thing to note is you can never trust a picture in geometry. So a lot of times they're going to give you a sketch to work with, something maybe like this, and when you solve all the algebra, you're going to find that this is like 110 degrees, and you're going to go, that doesn't make sense, 110 degrees, that's way too small, right? That should be an obtuse angle. Well, the reason why they're doing that is because a lot of times in geometry, they're assuming that a sketch is just a sketch. They might give you information like two angles are adjacent, and I might draw adjacent angles like this, whereas the person next to me might draw them like this. Well, that means that these adjacent angles in my picture are very small compared to slightly larger in the next, compared to somebody else who's drawing absolutely huge adjacent angles that are very unequal. And that's all fine. But when we do our algebra, we should all get the same answer despite the fact that we've all drawn different pictures. So they're going to get you kind of used to that by drawing some pictures that maybe won't match up with the answer. And it comes down to this guiding principle. Don't trust a picture. It's like we're getting into internet dating here, all right? You can't trust what it looks like. So always just trust your algebra over that. If you get an answer and you're like, it doesn't seem to make sense with the picture, it's okay to double check with me if the picture should be somewhat accurate, and I'll tell you yes or no, no problem. We're not trying to trick you. It's just intended to be a sketch to help you out. All right, so the homework is listed. There are problems out of the book, and they are posted on both Classroom and on Fax. So check those out. Don't be afraid to send me questions in form of email or by dropping a comment below. Hope you guys have a great night.